Hello friends, this is the third lecture of our example number 1, which is the design of gantry girder. Okay, so students, in the first two lectures we will discuss about our step number 1, which is the maximum reaction or maximum wheel load. Okay, in this step you can see that in this step, we have to find out how much load transfer from crane girder to gantry girder. Okay, and on one gantry girder there is two wheels. Okay, you can see that in this figure there is two wheels over here. This is wheel number one and this is wheel number two. So in the first step, we have to find out how much load is transferred from crane girder to gantry girder. After that, in the step, in the second step, we have to find out maximum bending moment which is generated on a gantry girder. So students, in this step, we have to find out maximum gantry girder with the help of absolute bending moment method. Okay, and with the help of absolute bending moment method, one statement is there: the maximum bending moment on a gantry girder generated on a distance b by 4. Now b by 4 is the wheelbase divided by 4 from the center of the span of gantry girder. Okay, it means your span of gantry girder is 7.5 meter. Now the center of gantry girder is 3.75 meter. Okay, so your one wheel is at a distance of b by 4. It means your wheelbase divided by 4. So in the question, it is clearly mentioned that wheelbase is the center to center distance between two wheels is given as 3.5 meter. So 3.5 meter divided by 4, which is 0.875. Now this 0.875 meter from center of the span. So at that distance your one wheel is there and your second wheel is at a distance of 3.5 meter because the wheel base distance is 3.5 meter. Okay, so in the last lecture we will discuss up to our maximum bending moment, which is 681.85 kilonewton into meter. Okay, now your step number 3 is maximum shear force generated in a gantry girder. Now repeatedly, what is gantry girder? So whenever your god gantry girder is there, so this is your gantry girder. You can see that this is your one gantry girder and this is your second gantry girder. Distance between two gantry girder is called as crane girder's length. Okay, so in the third step we have to find out maximum shear force in gantry girder. It means you have to find out maximum shear force which is generated on this span. Okay, now this length is 7.5 meter. You can see that in this figure this length is 7.5 meter. Now you have to assume that at which point your wheel is moving and at that time your shear force is maximum. So you all know that if your crane girder is stopped at the center, then the shear force at both the end is similar and it is half-half. But we have to design any component for maximum shear force and maximum bending moment. Now we have to find out maximum shear force, and you all know that your maximum shear force is generated when your gantry girder is moved and it is stopped at any one end of the gantry girder. Okay, so if you have to assume that this is your 7.5 meter span and if your crane girder is stopped at this end, so at that time this is your RA and this is your RB, reaction at A and reaction at B. So whenever your crane girder is stopping at that time your reaction at A is maximum. Similarly, sometimes your crane girder is stopping at this point. So at that time your reaction at B is maximum. Okay. So now let us start. It is assumed that our crane girder is stopping at the left support, and just like this, you can see that this is your RA and this is your RB. So for third step, we have to find out maximum shear force in gantry girder, and we have to assume that maximum shear force at A will occur when one of the wheel is at A point. So this is A point and this is B point. Now, our A point is subjected to point load, which is called as a wheel load of 300.75. This is also 300.75 and UDL is acting throughout the span. Okay, with the help of this figure, we have to find out RA and RB. So you can see that your maximum reaction is 471.83. It means we have to design our gantry girder for a maximum moment of 681.85 kN into meter, and we have to design our gantry girder for maximum shear force, which is 471.83 kN. Okay. Now, after finding out the maximum shear force and maximum bending moment, we are moving further to another two loads, which is surge load. Surge load is acting like this. Okay. When your trolley is moving like this and stop from one end to another end, then this trolley is subjected to axial force on gantry girder. So this horizontal force, it is also called as surge load. Okay, so the value of surge load is 10 percentage of hook load plus crab load. Crab means trolley. Okay, so it is 24 kilonewton. Okay, so students, this is the revision of our last lecture. Now in the last lecture, it is also discussed that there are number of sections are provided in the result scenario in the market, such as only eye girder, and on eye girder the top flange is with the rail section. This is your second I plus C, girder plus channel plus crane rail. This is I plus angle. So now in this example, we have to provided I plus channel section. Okay. So now let us start our step number 4, which is section selection. Now in section selection, we are trying to I plus C. Now one question is arise, if we are interested to provide it only I girder. No. If you are providing only eye girder, then your eye means in eye section. Your top flange is subjected and it is restrained to only bending moment in which is subjected to in vertical direction, and wave component restrained only shear force. Okay, now another force which is subjected to this type of force, and this force is surge load. Okay, so this surge load is restrained only when we are providing to C channel. That is the reason why we are providing I plus channel section in the design of gantry girder. Okay, so students, there is two assumptions which we have to make is economical depth of girder. It means this is for only I section. Okay, so this is economical depth of girder is L by 12. Now what is L? L means length of gantry girder, because we have to find out the design of gantry girder. It means we have to take only span of gantry girder, which is 7.5 meter, and this 7.5 meter is equal to 7500 mm divided by 12, so it is 625 mm. Second is width of flange. So width of flange, it means your I section, I girder's width is in the range of L by 40 to L by 30. Okay, now if we are taking the value of L is 7500 mm, then it is 187.5 to 250 mm. It means you have to selected your main section, main girder, which is I girder, having the total depth is less than 625 mm. This is economical depth, and you all know that if you are providing smaller depth, then your buckling is safe. Okay, and the second one is width of flange. It means you have to provide your eye sections width in the range of 187.5 to 250 mm. And third is ZP required. It means this ZP required is the K into mu by Fy. Now our maximum bending moment is 681.85. So you will get your answer 3820 cm3. Now you have to select it in such a way that your eye section having the depth of less than 625 mm, your selected eye section having the flange in the range of 187.5 to 250 mm, and your provided ZP is greater than 3820 cm3. Okay, now with the help of steel table, we are choosing our ISMB 600 with a channel section of ISMC 300. Okay, now what is the properties of ISMB 600 at 1.23 kilonewton per meter? So this property is find out from steel table. Okay, so you can see that the property of ISMB 600 having the value of ZP is 3510.63 cm3. A means sectional area is 15621 mm square. Okay, in the steel table, this value is written as 156.21, but it is in cm square. So you all know that our all the data in Newton into mm. So you have to convert your cm square to mm square with multiply it with 100. Okay, so it is 15621 mm square. Third is TF. TF means thickness of flange. So it is 20.8 mm. TW means thickness of wave is 12 mm. BF, width of flange. You can see that we have to provide it. Width of flange is 210 mm. Now, this 210 mm is in the range of 187.5 to 250. Okay, you have to provide it your width of flange in the between of 187.5 to 250. Okay, next is R. R means root radius. So the value of root radius is 20 mm. IZZ, for this IZZ is also called as IXX. So it is 91813.0 into 10 raised to 4 mm raised to 4. This IYY is 2651 into 10 raised to 4 mm raised to 4. Now, similarly, as calculated and as find out the property of ISMB 600, similarly we have to find out the properties of ISMC 300. But one important property is CYY. CYY means center of gravity for C channel, because you can see that your C channel is like this, and you all know that your only eye section is symmetric in both way, in x axis and in y axis. Similarly, your C channel is similarly when we have to cut from x axis, but it is asymmetric figure whenever we have to cut from y axis. That's why in the IS or in the steel table, CYY value, which is very most important, and it is 2.36 cm centimeter. It means 23.6 mm. Okay, now we are check we have to check our selected section is capable to take maximum shear force and maximum bending moment. So first of all we have to find out center of gravity of this combined section. Okay, one example is that if we are providing only eye section, so for only eye section the CG is exactly at the neutral axis, but whenever we have to provide it channel section at the top of the flange, it is our center of gravity is moved to upward direction, because we have to provide it some section at the top of the flange. Okay, so now we have to find out calculation of IZZ, IYY, ZB of trial section. So first of all, we have to find out the Y bar. Y bar means center of gravity in y direction. So you can see that this figure is symmetric in x-axis. X-axis means whenever we have to cut out this section from y section, then our x bar is remain similar. This is the mirror image. But whenever we have to cut our this section in x direction, then our this figure is not symmetric. Okay. So first of all, we have to find out y bar. Now, this is the similar of mechanics of solid in which we have to use A1Y1 plus A2Y2 divided by A1 plus A2. Now, what is A1? A1 means area of first member. So, we have to choose our first member is our I section. So, the area of I section is 15621 into y1 means our I section CG. So if your total depth of section is 600 mm, then we have to cut from center. Then the distance from our 0 0 is 300. It means this distance is 300 plus A2. A2 means area of our second member, and our second member is our general section. So our second member's area is 4564 into y2 means our CG from the origin. Now the total depth of I section is 600. Our C channel is like this. So this is the thickness of wave, and in the property you can see that the thickness of this wave is 7.6 mm. So our total height is 600 plus 7.6, which is equal to 607.6 mm. Now from 607.6 mm you have to put down the value is 23.6 mm, because in the steel table it is clearly mentioned that your CG of this C section is over here, and this is the distance of 23.6 mm. So we have to find out this distance, and this distance is 607.6 minus 23.6, which is equal to 584. So students, and our A1 and A2 is 15621 and 4564. So our combined sections Y bar is 364.20 mm. Okay. So it is already discussed that if we are providing some section at the top of the flange, your CG is obviously move on the upward side. Okay. So students, in today's session, we have completed our Y bars up to this point. Okay. In the next lecture, we are moving further to find out IYY and IZZ. Okay. So students, this is the end of today's session.